Welcome you all. Today I am going to explain one of the method to solve second order linear differential equation. So under that method of variation of parameter. So the general standard formula of second order linear differential equation is y double dash plus p into y dash plus q into y is equals to r, where p, q and r are the functions of x. Let us consider that equation y double dash plus p into y dash plus q into y is equal to r. Suppose the complementary function of equation 1 is c1 into y1 plus c2 into y2. I consider it as equation 2, where c1 and c2 are the arbitrary constant and y1 and y2 are the linearly independent solution of y double dash plus p into y dash plus q into y is equals to 0. I taken this as equation 3. We seek a complete solution in the form y is equal to v1 into y1 plus v2 into y2 in the variation of parameter method. I denote that as equation 4, where v1 and v2 are the functions of x. Differentiate equation 4 with respect to x. We get y dash is equal to v1 dash into y1 plus v1 into y1 dash plus v2 dash into y2 plus v2 into y2 dash. Here we are applying the a product rule of differentiation. I denote this as equation 5. Suppose v1 and v2 are chosen that v1 dash into y1 plus v2 dash into y2 is equals to 0. We choose the v1 and v2 such that they satisfies the condition v1 dash into y1 plus v2 dash into y2 equals 0. I denote that as equation 6. Then equation 5 becomes y dash is equals to v1 into y1 dash plus v2 into y2 dash. I denote this as equation 7. Again differentiate equation 7 with respect to x. We get y double dash is equal to v1 dash into y1 dash plus v1 into y1 double dash plus v2 dash into y2 dash plus v2 into y2 dash. Here also we apply the product rule of substitute equation 4, equation 7 and equation 8 in equation 1. We get v1 times of y1 double dash plus p into y1 dash plus q into y1 plus v2 times of y2 double dash plus p into y2 dash plus q into y2 plus v1 dash into y1 dash plus v2 dash into y2 dash is equal to capital R. Since y1 and y2 are solution of equation 3, the sum y1 double dash plus p into y1 dash plus q into y1 becomes 0. Similarly, this sum also becomes 0. Hence, we get y1 dash into v1 dash plus v2 dash into y2 dash is equals to capital R. Hence, using equation 6 and equation 10, solve for v1 and v2 from any method, but I use a Cramer's rule. I get v1 dash is equal to minus y2 into r divided by capital W and y2 dash is equal to y1 into capital R divided by W, where W is the Wronskian of y1 and y2. So that is defined by determinant of y1, y2, y1 dash, y2 dash. Thus, when v1 and v2 are chosen such that equation 6 and 10 are hold, then y given a equation 4 is complete solution of the equation 1. Now come to the working rule and a method of solving using variation of parameter method. Step 1. Write down the given equation in standard form, that is y double dash plus q p into y dash plus q into y is equals to capital R. Then find a CF, that is complementary function, in the form yc is equal to c1 into y1 plus c2 into y2. Denote that as equation 2. Step 2. Assume that the complete solution is in the form y is equal to v1 into y1 plus v2 into y2. This is obtained by changing c1 and c2 by v1 and v2 in equation 2. Step 3. Evaluate v1 dash and v2 dash using the formula v1 dash is equals to minus y2 into capital R divided by w, and v2 dash is equal to y1 R divided by w. So as we know, w is a round skin of y1 and y2. On integrating v1 dash and v2 dash, obtain step 3 to get v1 and v2. Put these values in equation 3, then we get a complete solution of given equation 1. See one example solving the problem by the method of variation of parameter. Given problem is d square y divided by dx square plus y is equal to tan x. Solution. Given equation is d square y divided by dx square plus y equals tan x. This one also written as capital D square plus 1 into y is equals to tan x. Consider auxiliary equation of given equation is capital D square plus 1 equals 0. Taken plus 1 to the right hand side, d square equals minus 1 we get, which implies that capital D is equals to plus or minus of square root minus 1, which is nothing but capital D equals plus or minus I. Therefore, a complementary solution is CF is equals to C1 into cos x plus C2 into sin x. Let us assume our solution is to be y equals V1 of x into cos x plus V2 of x into sin x. I denote that as equation 1 be the complete solution of given equation by the method of variation of parameter, where v1 of x and v2 of are to be found. We have y1 is equal to cos x, its derivative y1 dash is equal to minus sin x, y2 equals sin x, hence its derivative y2 dash equals cos x. Therefore, their Wronskian W is equal to y1, determinant of y1, y2, y1 dash, y2 dash is equal to determinant of cos x, sin x, minus sin x, cos x. So evaluating determinant, we get cos square x plus sin square x. So cos into cos, cos square x, minus into minus plus, sin into sin, sin square x, which is nothing but 1. And also we know that RHS of the problem, that is capital R equals tan x. Therefore, v1 dash is equal to minus y2 capital R divided by w is minus sin x into tan x divided by 1, which is equals to minus sin x into tan x can be written as sin x divided by cos x, which is equals to minus sin square x divided by cos x, that is equals to minus sin square x can be written as 1 minus cos square x whole divided by cos x, which is equals to minus, separate the cos x with each term of numerator, we get 1 divided by cos x minus cos x, which is equals to cos x minus secant x, because after multiplying with negative term 1 by cos x is secant x, get negative sign, and minus into minus plus cos x, get v first term. v1 of x is equals to integration of v1 dash of dx is equals to integration of cos x minus secant x into dx, which is equals to integration of cos x is sin x and integration of secant x is log secant x plus tan x and plus k1 is a integrating constant. Similarly, v2 dash is equal to y1 into r divided by capital W equals cos x into tan x divided by 1, which is nothing but sin x. v2 of x equals integration of v2 dash into dx, that is equals to integration of sin x into dx, which is nothing but minus cos x plus k2 as a integrating constant. Substitute the value of v1 of x and v2 of x in equation 1. We get y is equals to sin x minus log secant x plus tan x plus k1 into cos x. This is the complete value of v1 into y1 plus v2 into y2. On simplification of these two, we get k1 into cos x plus k2 into sin x minus cos x into log secant x plus tan x. Thank you.